Hi, my name is Sarah Virnig, and today we will be going over our math homework questions from Module 1, Lesson 1, Chapter 1, Thinking Critically. I'm just bringing my PowerPoint up here so I can go over the questions with you. Okay. And our first question's directions say to place the digits 8, 10, 11, 12, and 13 in the circles to make a possible sums across and vertically to equal 31. So it's trial and error. You just try different numbers, add them up, and see what you get if it equals 31. Okay, so I put 12, 8, and 11 vertically, which adds up to be 31. 10, 8, and 13 horizontally, and again, that also adds up to be 31. Okay, and the next part of the question is we have 4 boxes, and we are to solve them. And this is just a quick example so we know how to do it, how to set up the problems that we're going to get. So here we see that 2 plus 8 equals 10. And on the top, we can see that 10 is in the middle and 2 and 8 are on the outside. And 8 plus 3 is 11. 3 plus 5 is 8. 5 plus 2 is 7. And if we're missing a circle, we can also see you can subtract. So you can do 7 minus 5 to get 2. And that's just another way to find the answer. Okay, so our first question that we had, we're missing the top right, the bottom right, and the bottom left. So our first step is I take 15 minus 7 to get 8, and I put 8 in the top right. Now that I know that that's 8, because 8 plus 7 is 15. You can take 20 minus 8, which gives you 12, and you can put that in the bottom right-hand corner. You can check it by 12 plus 8 is 20. And our last one, the bottom left, I took 12 minus 7 gives us 5. Or, no, that does not, yes, it does give us 5. Or you can take, what I did on the other side was 17 minus 12. That also gives you 5. So that's just another little way that you can do it. You can check it multiple ways. Just make sure that after you find the numbers, you go back through to double check to make sure that your numbers are correct. Okay, our next box, we have the top left, and bottom right that's empty that we need to find a solution to. So if we take our top right, that's the one that we have 2 numbers that we can work with. Well, actually, there's 3 numbers. So we can do 13 minus 6 or 21 minus 6 to find the bottom right. So when we take 21 minus 6, we get 15. 15 goes in the bottom right. We can check it because 15 plus 6 gives us 21. Next, we take 13 minus 6. That gives us 7. That goes in the top left. Check it by 7 plus 6 equals 13. And our last circle, we take 11 minus 7 gives us 4. And again, check it by 7 plus 4 equals 11. Our next one, this one is a little trickier. And again, we start by the bottom right because those are the ones where we have 3 numbers where we can subtract from to get an answer. Okay, so first I take 8 minus 3, which gives us 5. So we put that in the top right. We can take 15 minus 5 gives us 10. We can check it because 10 plus 5 is 15. Now our bottom left, we can take 12 minus 10 gives us 2. But when we check it, 2 plus 3 does not equal 6. 2 plus 10 does, however, give us 12. And so we know that there is no solution for this question because no matter what we do, one number will always be wrong, whether it's the bottom row or the top and bottom on the left side. So you just write no solution on the problem and you move on to the next. Our next problem we have is we have 8, 18, and 9 that we can work with. So we just take the bottom numbers and we just set it up like the other ones. We take 18 minus 8 gives us 10, and we put that in the bottom right. 16 minus 10 gives us 6. That goes in the top right. And we know that 7 minus 6 is 1. We can also use that 1 to make sure that 1 plus 8 gives us 9. We can take 9 minus 8 equals 1. And again, check your work. 1 plus 6 is 7. 10 plus 6 is 16. 10 plus 8 is 18. And 8 plus 1 is 9. Okay, our next problems. We have 9 tiles, and they're laid out on a table so that they make a solid pattern. Each tile must be touching at least one other tile along the entire edge. And these are 2 examples right here. Let me move myself so you can see that. Okay, so those are our examples. And our goal is to find the figures that have the least perimeter and which has the greatest. And then we're supposed to sketch out our answers. So I found that the greatest perimeter I came up with was 20, followed by 18, 16, 14, and 12, with 12 being the smallest perimeter. And so these are some examples of what the shapes could look like, and I drew them out for you. So check your work and make sure that you have something similar, and always double check to make sure that you're using 9 square tiles and that you do not go over. Okay, on to number 3. Number 3, it's a little trickier. We have a sequence of dot patterns, and we need to draw 2 more. So here's my drawings of an additional 2. Yours should look something similar, and I just alternated the colors as we add on another layer. Okay, and part of this question is also to find, let me see, I lost my spot. We find a sequence of it. So we see here that we add, each row that we add, we're adding plus 1 to it. So on the top we have 2, then we go to 3, 4, 5, and then 6. Okay, and on this one, it's just another way of showing addition and multiplication. It's drawn out instead of just wrote on, where we write it on paper. I'm sorry, this one. And this one right here, we're going to find 4 more equations that we can add to this. So we were given 1 plus 1, or 1 equals 1, 1 plus 4 equals 5, 1 plus 4 plus 7 equals 12, 1 plus 4 plus 7 plus 10 equals 22. Now we were supposed to find the rest of them. And you can see the pattern here. It's taking the last number. So if we did the 10, we add 3 to it. And we can confirm that by looking at the ones that were given to us, because 7 minus 4 is 3, 4 minus 1 is 3. So we are moving in increments of 3. So every time that we add a number, we're adding an additional 3, which makes our end product go up. And here's the equation that we use. 3n minus 2. We can always check it by plugging in a number that we already have. So I went with 5. So we take 3n minus 2, substitute 5 for the n, which would give us 3 times 5 minus 2. 3 times 5 is 15. Then we subtract 2, which gives us 13. And as you can see, 13 would be our next number in the sequence that comes after 10. Okay, let's try it again. For our 9th term, we set up the equation the same way, 3n minus 2. We substitute 9, n for n, so we get 3 times n minus 2. 3 times 9 is 27, subtract 2 gives us 25. 25 is our 9th term, If we add up all the numbers, we get 117. Okay, let's do the same thing to find our 10th term. 3n subtract 2. 3 times 10 is 30, so minus 2 is 28. So on our 10th term, our number is 28, giving us a total for 145. Okay. Now we have these figures to the right show us an addition pyramid, which with the numbers and the sum of the two numbers immediately below equal the numbers on the top. So as we see here, 3 plus 5 is 8, 5 plus 4 is 9, 8 plus 9 is 17. Okay, and we're going to use this knowledge to help us on the 3 pyramids coming up. Okay, in our first one, we have 25 at the top, nothing in the middle, and we have x, 7, and 3 for our bottom. Now, to find the answer, we're going to need to find x first. So we know to find this middle left box, we're going to take x plus 7 will give us this. Now, on our right side, we know that 7 plus 3 gives us 10. So we already know that that number is going to be 10. So in another way we can do, since we know this is 10, we can take 25 minus 10 would give us 15. 15 minus 7 gives us 8. And then we just go work our way back up to check it. So 8 plus 7 is 15. 15 plus 10 gives us 25. Okay, in our middle box, we are looking for y that's in the middle and the bottom, and our two numbers that are in our middle row, and we know the top must equal 15. Okay, so we're going to look for y. So on the first one, on the left side in the middle, we have 1 plus y. On the right side, we have y plus 2. Now to find y, we set up an equation that looks like what I wrote right here underneath the triangle, or the pyramid, and it is 1 plus y in parentheses plus y plus 2 in parentheses equals 15. Now what we do from here is we combine our like terms. So we have 2y plus 3 equals 15. Now to get rid of the 3 on the left side, we must subtract 3. And whatever we do on the left side, we must do on the right side. So we subtract 3 on the left side and the right side. So that leaves us with 2y equals 12. Now to get y by itself, we divide by 2. Remember what we do on the left side, we also have to do on the right side. So 2y divided by 2 gives us y. 12 divided by 2 gives us 6. So we know that y equals 6. And with y equals 6, we can plug that in on our bottom. So 1 plus y, which we know is 6, gives us 7. Y plus 2 gives us 8 because, again, y is 6. 8 plus 7 gives us 15, which we get on the top. Always make sure that you check your math as you go. Okay, and our last one, this one is a little more challenging. So we're going to take, we're looking for our bottom, middle, and our middle ones on the second row. We know that 2 plus something gives us z, and again, something, we can call it z. Also, plus 9 gives us another sum. We know that z plus what we get over here will give us 27. So first we need to find what z is. And we need to find what we're looking for to set up our equation. So we take 9 minus 2, which gives us 7. So it's a difference of 7 between the 9 and the 2. Then we set up our equation, z plus, in parentheses, z plus 7 equals 27. And again, we're going to combine our like terms, which we get 2z plus 7 equals 27. Now we need to get rid of the 7 on the left side. So we subtract 7, and again, doing the same thing on the right side. So now we have 2z equals 20. Now we need to get z by itself. So we take each side, divide it by 2 to get z equals 10. So z equals 10. So we put z where z is. We're going to put a 10 there. So we know that 8 plus 2 gives us 10. And we can check it because 10 minus 2 is 8. 8 plus 2 is 10. Now, if we know that this is 10, to find the right box on the middle side, we can take 27 minus 10 gives us 17. 17 minus 9 gives us 8. Now we can work our way back up and check it because 8 plus 9 is 17. 17 plus 10 is 27. And now that that is done, we may move on to our next question. Okay, so this one, we have 4 married couples belong to a bridge club. The wives' names are Kitty, Sarah, Josie, and Ann. Their husbands' names are David, Will, Gus, and Floyd. So we're going to use this table to figure out who is married to who or whom. And the information we have that's been given to us is Floyd is Josie's brother. Josie and Gus dated some, but then Gus met his present wife. Kitty is married to Will. Ann has 2 brothers. Ann's husband is an only child. So we can see when we have information given to us and we're trying to figure out a problem like this, we want to first read through all the information that they give you before you start trying to figure anything out, because you could miss something if you just read the first line or 2 and then skip ahead. So what we're going to do is we're just going to go through it and mark off what we do know. So we know that Floyd and Josie are not married because they're siblings. So we can put an X there. We know that Josie and Gus dated some, but then Gus met his present wife. So we know Josie and Gus are not married. We know Kitty is married to Will. So by that, we can mark that Kitty and Will are married, which means nobody else can be married to Will, and that Kitty is not married to anyone else. So that eliminates those possibilities. Okay, now we know that Ann has 2 brothers, and also that Ann's husband is an only child. So by knowing that information, we can confirm that Josie is married to David. As she is married to David, no one else can be married to David. Now that leaves us with Sarah, Ann, Floyd, and Gus. Okay, so we know that Ann has 2 brothers. We know that Ann's husband is an only child. Okay, so taking that information, and we're going to read that first line that says, Floyd is Josie's brother. Floyd is not an only child. Therefore, we can rule Floyd out. So Ann is married to Gus, leaving us with only one option for Sarah to be married to, which is Floyd. Now, when we have it all done, we can just read back over it to make sure that we didn't miss anything and that we have all the information correct. So we're just going to kind of check it off as we go through. Floyd is married to Josie's brother. Floyd is Josie's brother. They're not married. We have an X there. Josie and Gus dated some, but then Gus met his present wife. So they're not married. We have an X there for Josie and Gus. Kitty is married to Will. We have a check mark there. Ann has 2 brothers, and Ann's husband is an only child. So as we read back through it, we make sure that we have everything correct. That leaves us with Kitty is married to Will, Sarah is married to Floyd, Josie is married to David, and Ann is married to Gus. Okay, on to this problem. We have a trapezoidal numbers 1 plus 1 plus 1. It's the same as 1 times 3. And I just drew it out right here. We have 3 dots showing that we had 1 plus 1 plus 1. Our next one is 1 plus 2 plus 2 plus 2 plus 1. It's the same as saying 2 times 4. we have 2 rows and 4 in each. Now our next one, our numbers are increasing. So we have 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1 equals 3 times 5. And we can see here I have 3 rows of 5. We can also make sure that it's correct because we know that 3 times 5 is 15. And if we count up each dot, we get 15. So this is another way of learning how to do multiplication. Seeing the numbers, seeing the dots, we can count them up. We also can check it by either adding all the numbers up or doing the multiplication. Okay, so our next one in the series would be 4 times 6. And we are increasing by 1 on the left and the right side. So we started out with 1 times 3, 2 times 4, 3 times 5. Now we move on to 4 times 6, which gives us 24. Our next one is 5 times 7, gives us 35. And then we have 6 times 8. So every time that we increase, we're just increasing by 1 on both sides, which means when we increase, our rows get longer and our columns get longer because we're increasing the number that we get as we work. Okay, and here's an equation so that we don't have to sit there and count out every little dot. This makes it faster and it's a lot quicker to use this equation. N times n plus 2 in parentheses. Now, we're going to put 5 in, as we already know what the answer is, because we did it on the previous slide, but we're just going to check it. So we put 5 in for n, which gives us 5 times 5 plus 2 in parentheses. And we always remember our order of operation, PIM does. So we're going to do what's in the parentheses first, and then we work to outside of the parentheses. So 5 plus 2 is 7. 7 times 5 is 35. We can also check that because 5 times 7 is 35. When we go back to my previous slide, we can check right here because we can also count the dots and we would get 35. Okay, our next one is we're going to check for the second term just to make sure that we're doing this right. You can always work through one example that is given to you or more than one example so that way you feel familiar with it and you know how to solve it when you don't have an example in the answer to fall back on. So n times n plus 2. We're going to put 2 in for n. 2 times 2 plus 2. Remember, we're going to do the work inside the parentheses first and then move out. So we're going to do 2 plus 2 is 4. 2 times 4 is 8. And again, we can count the dots and we would get 8, or you can add 1 plus 2 plus 2 plus 2 plus 1, and it will also give you 8. Our next one is we're going to do find n for the 7th term. So we're going to set the equation up the same way, n times n plus 2. 7 times 7 plus 2 in parentheses. And then 7 plus 2 is 9. 9 times 7 is 63. And if you want to take the time to add up all those dots, I promise it equals 63. And I should have explained too, PIM does. It's parentheses, exponents, multiply, divide, add, subtract, whatever comes first when you move left to right. But we always start with parentheses because that's separate. Okay, and moving on. That was our last one. So I hope that you enjoyed my presentation. And if you have any questions, please let me know. There's my name and my email address. Okay, thank you. Have a good day.